All right, so we're continuing with another problem set that now is combination of series and parallel. So this is parallel, but within parallel you have series. So you have parallel where things split over here. So in this junction it splits, but you also have series within this parallel. So you have series over here. So what you need to do is you have to figure out a voltage that's going through the R1. You need a V1, and you need V voltage that's going through 2 and 3 both and through this pathway. And so that is easy because it's parallel circuit. So you have 5 volts going this way. And because it's a parallel circuit, you're going to have 5 volt going upward to the resistance 1. And you're going to have another 5 volts going to the R2 and 3. So V1 and V2 3 is actually both 5 volts. All right, so then the question is, if it's 5 volts going through, then how much current is actually going to R1? So what is I1? And I1 is equal to V over R, V1 over R1. And V1 over R1 is 5 volts over R1 is 1 ohms. So it's going to be 5 amps. Okay, so it's exactly like the series circuit, except it's parallel, but because it's a parallel circuit, the voltage doesn't drop. Now with R2 and 3, you can figure out this entire voltage going to this line of circuit is 5 volts. So I23 combined, so the current that's going through the both resistors number 2 and number 3 is equal to V23, and V23 means voltage of this green area all over resistance of 2, 3. Now resistance of 2 and 3, they are connected through series. So over here, this line, it has only one path connecting between R2 and R3. So this is a series connections. So if the two resistors are connected through series uh, connection, what you have to do is you have to add them up. So R2, 3, since they're series to each other, you have to do R1, R2 plus R3. So in this case, R1 is 1 ohms. R2 is 1 ohms. R3 is 1 ohms. So when you add them up together, you get 2 ohms. So R23, not 23, but 23 combined is 2 ohms. So in this case, V23 is 5 volts. R23 is 2 ohms. So I23 is 2.5 amps. And because they're connected through the series, so in series, all the currents are equal. So I23 is equal to I2 and is equal to I3. So here I2 is 2.5 amps and I3 is also 2.5 amps. Okay. All right. So I think we can do another questions. Oh, the voltage of R2 and R3 on the other hand, because there's a 5 volts going there, but this 5 volts is being shared among R2 and R3. So if we look at the resistance 2, so if we only look at the resistance 2 now, and if you were to ask what is V2, right? V23 is 5 volts, but what about just V2? What is V2 equal to? And so V2 is equal to I2 times R2. And V2 then is equal to I2, which we got it here as 2.5 amps, so it's 2.5 amps, times by R2, which is 1 ohms, which is given to us. So you get 2.5 volt. Okay, and same thing with the V3. V3 is equal to I3, the current at the resistor number 3 times resistance 3, and then V3 is equal to I3, which is 2.5 amps. So it's 2.5 amps times by R3, which is here, which is 1 ohms. So then voltage at resistance 3 or resistor 3 is 2.5 volts. Okay, so there's 2.5 volts and 2.5 volts. So V23 is equal to 2.5 plus 2.5. So that together gives you 5 volts, which I already knew before. We said V23 is equal to 5 volts. Okay. All right. Let's do another question.